microphone right now to see if this thing's working. Hi, my name is Ryan and welcome to the Java Dog String Text-Based Adventure program. We're going to walk you through a little bit about strings and how to use strings, and we're going to make a kind of a semi-text-based adventure program. Nothing too complex. We just kind of want to get the basics down to learn strings so that way we can start getting ready for, more advanced things in Java, plus the AP test. Making a text-based adventure does require strings and a lot of other elements, but we wanted to focus mainly on strings just to get used to it. So let's see what we got going on here. Okay, so your end product, when you get done, if you copy everything that I do, you'll notice down here in the console, we're going to ask which room we want the user to go to, and we'll have some predefined terms, and we'll say we want to go to room 2. Okay, and then down here, after that runs, okay, I need to make my console larger. It says, looks like you want to go to room 2. Then we say some other stuff in here. We try to be silly and fun and omnipresent or whatever it is called. Okay, down here are a list of some action words we give the user. Ideally, you probably want to accept a lot of different terms from the user, especially from their natural language. For now, we're just going to focus on giving some action words that you can use to perform certain actions. And then down here, we're going to prompt the user to type in if they want to exit or if they want to continue. If we type in exit, we're going to kill the program off. Okay, and we'll exit the program. We're going to use this game over method, and it's going to basically shut down the program. However, we want the user to be able to run the program, so let's go back to room 2. Now, I choose room 2 because room 1 is more of a practice room, just getting used to switch into an object to print out some console information. So room 2's got a little bit more definition to it. Let's go ahead and click on continue, press enter, and then there's some more text coming up. It says you did not type exit, so it looks like you are stuck in my mind maze for a while. Evil laughter.
Talking about rabies.
All right, and then here's some of the story. You can change the story. However, I saw that movie It, and I was thinking about clowns, so I thought, you know what, let's roll some clown stuff here. So the central room you're staying in reeks of some horrible smell that reminds you of an uncomfortable situation while in clown college. So we're going to assume that you were in clown college. Okay, but that's not the real main point. And you notice my text kind of goes off the screen here. No big deal. We can easily, use the courage trying to get it kicked down to the bottom side. We're telling the user they have to escape immediately. Right here in the text, we give them some hints. They can see stairs that go up and a door on the east side of the room. Those are terms that they will use based upon the action terms up here. Notice we got east, we got walk, run, swing, and then we have the word up and down. Okay, so what we'll want to do is we want the user to be able to type in where they want to go. So where do you want to go? Let's just say east room. Press enter, and you should be able to go through the east room. Some more story here. Then it tells you, do you want to go up downstairs or pick up the disguise?
List of information.
Let's say pick up the disguise. All right. And then we give the option to store the disguise in inventory. So we're going to use an array list of string types to store the disguise. Let's go ahead and store it, please. All right. So right here we gave them an output that says you stored the disguise, and then we tell them how many items are in their inventory. So we just cycle through the array list and print it out. I probably should edit that a little bit so that line goes below it. We'll get that cleaned up. No big deal. And then it says after storing the disguise, there's little time, so you hurry down the stairs. And here, I didn't continue on the story because I wanted you to continue on the story since I'm giving you all the main part of the code here. I went ahead and designed a kill switch into the program, so once it gets to that particular method that's calling the object to start running the room to downstairs method, so we continue on that part of the story, we go ahead and kill the program so that way you can go and fix it. So that's essentially what you're going to do. However, we're going to start off with some beginning level steps here to get you used to manipulating strings. So with further ado, let's go ahead and get started. Go ahead and open up a brand new Java file. You can do that by going File, New, choosing Java, and we're going to want to start off with importing our scanner, and I'm going to go ahead and put that in there. And let's go ahead and create our public class. We're going to call this string, adventure control. Okay, nothing really fancy in the name. It's just something I want to roll with. So we got string adventure control, and before I forget, let's go ahead and save that. Don't look at my directory because mine's a little bit different than yours since I pre-made these lessons. I need to create my folder. So I'm going to go ahead and I got my new folder here. We'll call it string adventure programs. Hope I didn't misspell that. All right, press enter, go to my string adventure programs. And here we got string adventure control. I'm going to go ahead and save it right there. All right, so here we go. I'm going to make sure I've got some proper indentation here. And let's go ahead and get our public static void, almost put void main string args. And then from here, we're going to create a list of variables. I want to copy and paste these things just so we can move on a little bit quicker, especially since there's a lot of redundant information here. Okay, if you can figure out how to copy and paste off YouTube, I will give you a sticker. All right, right here we're going to create a scanner variable called input1. It's like you've seen before, so we're creating a brand new one. Okay, new scanner object called input1. And then here we print out a couple lines of text. We tell them this is an adventure, and we're going to enter in your name. And we want to use our new scanner object. And go ahead and print it right there. So the name will get assigned a value from the next line statement of the input1 object, and the user will enter in their information. Next, we are going to, I'm going to go ahead and give you all this code right now, and then we'll go ahead and get this working. All right. I am not liking JGraphs these days. I think I'm going to switch over to a new IDE. It never keeps all my alignments, and I'm spoiled with Visual Studio because I like to use that with Unity more than I use JGraphs. Anyhow, enough of my complaints. JGraphs is great software, but it's testing my patience today. Maybe I drank too much coffee. All right, anyhow, next line of codes. We're going to tell them to welcome to the adventure. We print out their name just so they know that we're legit, that we can print their name out on the console here. And then, again, we tell them their name again, just because, we want to let them know we're serious about this. And then here we're going to call a method that we have not created yet called string checker 3000. And what this string checker 3000 method is going to do, or excuse me, class, it's going to perform a method called name data, and we're going to assign it to a string value, and then we'll print it out right here. Let's go ahead and we're going to create a class below this one. Let's get these curly braces lined up here so it's not so messy, and we're just going to embed this class in the same file. This is not good to do it, but it's not bad. It's kind of one of those things, kind of like, should you put your ketchup in the fridge or should you store it in the cabinet at room temperature? That's a big question. I see a lot of debate. Y'all probably want to get on Twitter and check that out and have a battle of the minds. See, ketchup stored at room temperature or ketchup in the fridge? It's up to you. Anyhow, in our case, we're going to embed this class right here, or in the same file, called string checker 3000, and we want to make sure we got a public static string name data. Was that? Yeah, that was the name of them. And we're going to create a variable that's getting passed into this parameter here called str. That's my favorite name for strings. And with the string name data method, we're going to put some information in here. I'm going to just copy and paste all this because it's easier if I just do it at once. Then you can copy it all at the same time, and then we can walk through it together, hand in hand, explain this thing, just like cats and dogs celebrating Thanksgiving with each other. It's just awesome. Okay, right here, we're going to create these three variables. They're all strings. Temp string U, that's for uppercase. Temp string L for lowercase. I use a capital L. I realize the irony of that for you people paying attention to that. Then we have a another variable here called total concat string. That's for concatenation of the string. Now right here on lines 33 and 34, I take the variable that we passed, str, the string, which is what came from right here, and I pass it into these methods that change everything to uppercase, and then this one changes everything to lowercase. Okay, I just want you to see that you can switch these things, and this is a legitimate strategy on dealing with string data, getting input into a form or something. If you ever use Access Database or forms in Excel or anything like that, that's something you would get used to doing. So right here, total concat string, what we'll do is we'll take this string literals and concatenate it with the variable information that I'm passing into it, such as the uppercase string, the lowercase string, and then we're giving the length of the string. Okay, I just want you to see that you can do all these different things. And then right here, check this out. We get the first letter of their name by using the substring of 0, 1. Okay, so it goes from the 0 index position, which is the first one, to the second letter, which is index position 1. But remember, this only goes to whatever n to n minus 1 is, whatever that is. Okay, so it goes from 0 to actually less than the second value, which is 1. So it's going to get the first letter, 0, 0. All right, then right here, the last letter of your name. This is where we get fancy. Okay, this is where we earn our money for ketchup. Is that we're going to get the substring. We're going to get the string length of -1. So say we have 10 letters in our name. You may not, but let's assume you do, maybe. So this value would be 9. Okay, so if we have 10 letters in our name, this value would be 9, and then this one would be 10. So it will get the last letter, because the last letter is at the 9th position. Remember, we start counting with 0 on these values. And then right here, we turn the value, which is a string, it's getting returned back, into this method right here. So let's save this happy little program, and let's clear this out. Let's run it. Hopefully got no compile errors. Oh, yes, none. That makes me feel good. My name is Ryan. And there we are. It says, oh, that looks sloppy. It says, Ryan, first we're going to analyze your name, uppercase, lowercase, letters. First letter of my name is capital R. Last letter of my name is N. Okay. Now let me do something real quick, because that looks bad right there. Hold on, where did my console did it show up? It says, Ryan, first we're going to analyze your name. That is right here. And we should probably, let's make that lowercase f, just so we look like we passed English class at some point in time. Okay, let's try, see how that looks again. All right. Oh, that still looks horrible. I promise you, I'm much better at writing than this. Okay, there we go. Boom. It's going to look nice when we run it. There we go. All right, perfect. So that is the beginning of that program. Next, we want to kick this up a notch. We're going to spell the name backwards, okay? And it's easier said than done, okay? And so let's go back up here to our string adventure control. I'm going to move the console down so we got some more room to see our code. And I'm going to copy and paste in the reverse part of this program. And look at JGrasp. It's challenging my ability to concentrate with poor alignments. All right, so now we're going to spell our name backwards, and we're calling on the string checker 3000 class again, and we're going to call a new method called name reverse. If we try to run this program, it's not going to work, because guess why? We haven't made this method yet called name reverse. And we're going to pass it in the string variable called name, and you can assume that this is going to have a method of the same value. So let me go ahead and copy and paste that over, and hit Control C and come on over. There we are. That's I'll take it today. All right, so the name reverse class, it's public static capital string. If you don't know why I have static, go to Stack Overflow, look on Google, and figure out why does he have to have the word static in a class that's nested in the same file as something that has a static method of main. You might want to go look that up, or go watch the other video where I explain that. All right, name reverse. We're taking the string, passing it in. Right here, we take the temp reverse. We give just a temporary value of kind of like a blank spot right here. And then I take a for loop, and I'm going to get the length of the string right here. And long as, which is assigned a value I, and as long as I is greater than 0, I'm going to keep subtracting 1 from I. And here, we're going to get the substring value of that string, and we're going to start at I minus 1 and get the other index position of just I, and we're going to assign those letters to temp reverse. And actually, we're you see the add equals, that means we're concatenating this letter that we're pulling out here to this whatchamacallit, to this variable here that's just going to keep adding to it, and it's going to spell it backwards. So remember, say my name Ryan, it has 4 letters inside of it. Let me just go ahead and type that up here for you. So the N is technically at the say at the 3 position, because remember this is 0, R is 0, Y is 1, A is 2, N is 3. So right here, the length of this is technically 4, but right here, I gets minus 1, so that's 3, okay? So that's 3, and this value is 4. And the substring is going to return the letter N because there's nothing at the 4th position, okay? Because 4th position is technically blank, and Java's cool with that. It knows it's going to return everything less than that. So it's going to get what's at the 3 position right here and put it inside this variable right there. Then when the loop repeats itself, remember we're subtracting from I, so now I is going to be 2, and so this will be whoa, man, hold on a second. Yeah, I'm right. Okay, so now I is going to be excuse me, I is now 3. Okay, I is 3, and I is going to get 1 subtracted from it, which will put this as a value of 2, and then this will be a value of 3, and then the value of the 2 position will be right here, okay? Because remember, this is R is 0, Y is 1, A is 2, N is 3. So the A will be at the 2 position, and it's going to return that. And you can see that if we subtract 1 again, I will now be 2, and then when we bring I into the substring, since I is 2 minus 1, that's puts it at a 1 position, and this I is at 2, so that means that we're going to be returning the Y value and so on. Okay, so that's what's going on with this. And let's go ahead and save it and compile it. Remember, compiling it will automatically save the program for you. And let's run it, and we enter Ryan, and let me scroll up, and there's my name spelled backwards. Now I could have gone through and made everything uppercase or lowercase, but I didn't do that. I mean, you saw it happen up here. If you want to, you can go through and do that. Maybe I'll put that in part of the grading rubric, something you can do later, because that will be a lot of fun. All right, hopefully you understood all that, and we're going to do the next section where we're going to actually use the equals comparison tool for strings. You probably have seen this already. This is just kind of review material. Let me get that tabbed over. All right. So what we're going to do is ask the user to check their memory to make sure they know what their name is, and we'll have them input another value in and store it into a variable called name2. And then from here, we're going to check to see if name, which was the first one entered, right up where did I put that? I can't remember where I put that. Okay, so I'll remember here in a second. Oh yeah, right there. So we're going to enter in the name2, and we're going to see if the first name equals name2. And then here we're also going to just show you the difference of using the compare to name2, and we'll print these out so you can see what happens. Now there's no need to worry about string checker 3000. We're technically done with that. You don't need to worry about it anymore, so we won't have to call any more methods out of that particular class. Let's go ahead and run it. My name's Ryan. Okay, let's check your memory. What is your name? Let's type it in all caps. Ryan. Let's see what happens. All right. And it says the equal check, the results of this are false. And then right here, the results of this are 32 on the compare to. So why in the world would this give us false and this would give us 32? Let's think about this. Okay, I entered in my name first as Ryan with a capital R, then lowercase y-a-n. Down here I entered in all capital letters. Okay, so this first equals, it returned false because this name and this name, those two objects are not equal to each other because uppercase and lowercase have different values. The compared to works a little bit different. It's going to return a value that's a 0, a positive number, or a negative number. If it's 0, that means the values are equal to each other. When it returns a positive value, that means that the first entry is greater than the other value on the Unicode scale. So Ryan, R-Y-A-N, okay, these have a greater value with the lowercase values than the all caps. And let's run that again just so you can see the difference here. I'm gonna put a lowercase r for the first one and then capital R for the second one. And you can see right here that they're not equal, that the lowercase r is higher on value than the capital R. Okay, and just run it one more time so you can see a little bit more of a difference here. Enter my name. I'm going to put in A and then B, and then right here you can see that again it's false, but A is less than B is on the scale. Okay, we're not going to get into the scale because this video is running long. You really need to know that at this point in time with your AP material, but you just need to know that the compare to gives you a 0 if they're equal, a positive value if they are if the first value is greater than the other or the second value, and negative if the first value is less than the second value. Here I entered in capital R's for both of them and returned to 0. Okay, and last but not least, this one's pretty easy. We're going to go ahead and look at some word trimming here. Okay, promise this is the end of this video. I just want to wrap it up. I didn't want a second video for this entry-level stuff. So right here we're going to remove some spacing before and after words, and again we'll get the input from the user. It goes to word entry variable, and then here we get the length. We'll trim up the length on this line. On line 30 we call the trim method. So whatever we enter, if there's empty spaces before or after, we're going to trim that out, and then we will get the length of that new value which got assigned right here. So let's go ahead and run that, and it runs everything unfortunately, so I'm going to put in multiple spaces of R, and then doesn't matter about that. Okay, let's see, enter in some words with spaces or after them. I pressed 5 there, type in Ryan, 1 2 3 4 5, press enter, and I should have the console up higher. Okay, so the total entry is 15 spaces. However, once we ran trim, which is right here, it trimmed out all the empty space before and after this entry right here, and it reduced it down to just 4, basically 4 units in the length of this word that's entered. Let's do it again. All right, so my name, doesn't matter what we put right here. So I'm gonna hit 1 2 3 4 5 6 7, and I'll put in Fred, then 1 2 3. So there's 7 in front, 10 on the back, plus the 4 right here. That gives me 14 total. And then once it trimmed it, reduced it down to just 4. Okay, because remember, 4 is for the total values of the letters. If I had 7 blank spots in the front and 3 on the back, and that is what leads us to this. Okay, so that is the end of the video. Thanks for watching. Make sure you subscribe, follow, find me on Twitch, find me on YouTube. I don't care. Just keep watching, and we'll get into the next section. And thanks again.